So on the basis of the directive influence of the group, second group which we will be going to study is meta-directing group. So what is meta-directing group? These groups which are present in the benzene ring will initiate further electrophilic reaction at meta position. It means they will direct next incoming group to meta position. So these are known as meta-directing groups. So there are many examples of meta-directing group. Examples: cyano, nitro, carboxylic acid, aldehydes, ketone, ester, sulfonic acid, and many more examples of meta-directing group. These are electron withdrawing group. So in this case, the reaction, that is electrophilic substitution reaction, is taking place in meta position in the presence of these meta-directing group. Example: nitration. So let's see what is happening in this case. So if we take nitrobenzene and react it with mixture of concentrated HNO3 in the presence of concentrated H2SO4. This is electrophilic substitution reaction. In this, the electrophile which will be generated is nitronium ion. So what is happening in this case? This reaction is taking place at 393 Kelvin. So there is a formation of NO2. This is dimetanitrobenzene. In this case, the electrophile is attacking at meta position and removal of H2O. So by the help of this reaction, it is clearly understood in the presence of meta-directing group, electrophile is attacking at meta position. So what is the reason behind the meta-directive influence of these substituent group? So in the case of meta-directing group, what is happening? If we take example, this is benzaldehyde, this is CHO group. So why this CHO group is having meta-directive effect? Because the atom which is directly attached to the benzene ring is forming a multiple bond with the electronegative atom. So what is happening in this case? This electronegative atom, we know that oxygen is second most electronegative atom. So this electronegative atom will attract the pi electrons of this multiple bond. Because of that, this carbon will become electron deficient, which in turn attract the electron of the benzene ring. So what is happening? This electronegative atom is making this carbon electron deficient. Because of that, this carbon will further attract the electrons of the benzene ring, due to which these groups are showing a meta-directive effect on the benzene ring. Because of that, the electrophile will attack on the meta position. There are some other groups also in which the atom which is attached to the benzene ring is not bonded by the multiple bond with the electronegative atom. Example CCl3, CF3, these are also meta-directing group. It means they are initiating electrophilic substitution reaction in meta position. But in this case, the atom which is attached to the benzene in this case, the atom which is attached to the benzene is not bonded by the multiple bond with the electronegative atom. Still, it is showing a meta-directive effect. It is because the atom which is next to this carbon are highly electronegative atom. Because of that, this group will attract the electron of the benzene ring towards itself. Because of that, they are meta-directing group. So let's see, it can be explained on the basis of resonance why electrophile in the presence of these group are attacking at meta position. So let's see what is happening if we take benzaldehyde. So in this case, oxygen is having two lone pairs. Further, so this oxygen is second most electronegative atom, so it will attract the pi electrons of this pi bond towards itself, due to which this carbon will become electron deficient. So this carbon in turn will attract the electron of the benzene ring, that is the pi electron of the benzene ring will be attracted by this carbon. So further, what is happening? There will be formation of negative charge will be coming on oxygen, and there will be formation of double bond between the carbon and benzene ring, and these two pi bonds are remain intact because this pi bond is shifted to this position, due to which the positive charge is coming on this position, and this is ortho position. So what is happening in this case? This pi bond will come to this position, due to which the pi bond is coming to this position, positive charge is coming to this position because the pi bond shifted to this position. Further, next canonical structure. So in this case, what is happening? This pi bond will be shifted to this position and positive charge is coming on this position. Further, so what is happening? This negative charge will come on this position, original position. So there will be pi bond formation between oxygen and carbon, and this pi bond will again come to benzene ring. So there will be formation of 3 pi bonds in benzene ring and double bond OH. So these are the 5 canonical structure: first, second, third, fourth and fifth. So these are the 5 canonical structure. So what is happening in this case? In the presence of meta-directing group, the electron density at ortho and para position is decreasing. As you can observe in these canonical structure, there is a decrease in electron density mainly on ortho positions and para position, whereas in meta position the electron density is less decreased in comparison to ortho and para. So because of that, these groups are meta-directing group, because in meta position the electron density is not that much decreased as decreased in the case of ortho and para position. Overall electron density in benzene ring is decreasing in the presence of these meta-directing group. Because of that, they are referred as electron withdrawing group and deactivating group. They are referred as electron withdrawing group and deactivating group. It means the reaction towards electrophilic substitution reaction will decrease in the presence of these meta-directing group. So what is happening? These groups are having minus R effect and minus I effect. Because of the minus R effect and minus I effect of these meta-directing group, the electron density in benzene ring is decreasing. Because of that, the electrophilic substitution reaction decreases in the case of these meta-directing group, because electrophile is always in the search of electron rich side, whereas in the case of these groups the electron density in benzene ring is decreasing. Because of that, the electrophilic substitution reaction decreases in the case of meta-directing group. What do you mean by minus R effect? It means the pi electron of the benzene ring is moving towards the electron withdrawing group, due to which this represents, it is showing that in this case the resonance is taking place, but in this case the pi electrons of benzene ring is moving towards the functional group. Whereas minus I effect, it means in this case these groups are also attracting the sigma electron of the benzene ring towards itself. In the case of minus I effect, the electronegative atom or electron deficient atom is attracting the sigma electron of the alkyl or phenyl system. So in this case, these groups are also having minus I effect. So they are attracting the sigma electron of the benzene ring towards itself, due to which the electrophilic substitution reaction in the case of meta-directing group is decreased in comparison to ortho and para-directing group, because ortho para-directing groups are showing plus R effect, due to which plus R effect, and they are also showing plus I effect. So what are the two cases which are observed in the case of meta-directing effect? First, in the case of meta-directing effect, these substituents are decreasing the electron density in the benzene ring. Because of that, the electrophilic substitution reaction in the presence of these group become difficult. Example, if we take So if we compare the rate of electrophilic substitution reaction in nitrobenzene and benzene, in this case, in the presence of nitrobenzene, the nitration reaction is very difficult in comparison to benzene. It is because of this nitro group. This nitro group is electron withdrawing group, so this will attract the pi electron of this benzene ring. Because of that, the electron density in benzene ring is decreased, due to which the electrophile, that is NO2 plus, which is generated in the nitration reaction, will not easily attack on this benzene ring, because the electron density in benzene ring is decreasing. Whereas nitration reaction in the case of benzene ring is much faster in comparison to this nitrobenzene. It means electrophilic substitution reaction is more in benzene in comparison to this nitrobenzene. It is because of the meta-directive influence of this nitro group. Second point, higher will be the electron withdrawing ability of the functional group, lesser will be the reaction towards the electrophilic substitution. Example, if we take nitrobenzene and compare it with benzoic acid. So in this case, this group is nitro group, whereas this group is carboxylic group. So in this case, the electron withdrawing capacity of this nitro group is much more in comparison to this carboxylic acid. It means in the presence of this nitro group, the benzene will become more electron deficient because of the higher capacity of this nitro group to attract the electron towards itself, due to which the electrophilic substitution reaction in the presence of nitrobenzene is less in comparison to this benzoic acid, because this carboxylic acid is less electron withdrawing in comparison to nitro group.